Okay, geometric word problems. Geometric word problems with quadratics means you're going to be dealing with shapes. More importantly, what you need to keep in mind is that unlike the ball and the air problems, where normally you were telling a story, there was a beginning, middle, and end because something was happening over time, in this case, you're going to be looking more at just the relationship between dimensions and the area. And why are we looking at the area? Well, when you have something squared, you're dealing with a quadratic, and in the real world, dimensions, when you have something times something, you end up with a square dimension. And so often we're looking at the area of a function when we're looking at a geometric word problem. Alright, so in this one, starting off, you have the perimeter of a rectangle is 24 centimeters. So 2L plus 2W is equal to 24. Then they tell you the area is 32 centimeters. Well, how do you get the area of a rectangle? Length times width. Okay, the question asks, what are its dimensions? Well, the dimensions are the length and the width. Well, the problem is we want to know what numbers those are. But what you've got is two different equations that have both L and W in them. So what you can do is solve it as a system of equations. That's exactly what it is. So pick L or W and solve for one of them in this one. It doesn't matter which one. And then get L completely by itself, so divide by 2. And I have that L is equal to negative W plus 12. Now that I have L completely by itself, I can take this and substitute that into the L in this equation. So what I have there is negative W plus 12. That's just where the L was. I'm going to bring down this W is equal to 32. Then I'm going to distribute this. That gives me negative W squared plus 12W is equal to 32. And since I'm trying to solve a quadratic, I'm going to set my right side, well, one side, in this case it's easier to do the right side, equal to 0. So what I have is negative W squared plus 12W minus 32 is equal to 0. Now you guys have learned 4 ways to solve a quadratic. You could solve it by factoring, completing the square, quadratic formula, but in this case, and generally with word problems, it's easier just to go ahead and get an approximation through graphing, because generally that's what they want, is just an approximation. So if you graph this, what you're going to see is that it crosses at x is equal to 4 and x is equal to 8. Now technically this is like a W. So the W could be 4 or it could be 8. Well, if W is 4 and you substitute that in here, negative 4 plus 12 is 8. If you choose 8 to be W, negative 8 plus 12 is 4. So either way, you're going to get the other number. So these literally are your two dimensions. So the dimensions are 4 centimeters by 8 centimeters. And I don't want you to just do stuff and give me an answer. I want you to really think it through. So you have the perimeter of a rectangle is 24. So we're dealing with a rectangle. And you found, or we found together, that dimensions are 4 by 8. Well, let's look at that and make sure that's true, that this fits the original requirements. So if the perimeter is the sum of all the sides, and they tell us it's supposed to be 24, 8 plus 4 is 12, 12 plus 8 is 20, 20 plus 4 is 24. So that does check out. The area is supposed to be 32. 4 times 8 is 32, so this definitely works, and these are your solutions. And this is your most, in my opinion, basic geometric quadratic word problem. You are given the perimeter, the area, you have to know those formulas, do substitution, solve your quadratic, and get your dimensions. The next one is a little bit tricky. hopefully this, okay. So right here what we've got is that the White House has purchased 450 feet of fencing. They want to create a rectangular recess area divided into 2 sections. And they want to know what are the dimensions that would maximize that area, and then what is that maximum area. Well, first what you've got to sort of think about is what they want. So they have 450 feet of fencing, and they want to create a rectangular recess area. So rectangular recess area divided into 2 sections. Well, I could divide it here or there. It really won't matter. We'll be able to figure out what's going to happen either way. So there we go. We have a rectangular recess area divided into 2 sections, and we need to figure out the dimensions. Okay. Well, that 450 feet has to be used to come up with every place there that's marked. So normally we have 2L plus 2W. I'm still going to call those L's, because those are the links going across, like all the way across. And I'm still going to call these W's. But for the purposes of our fencing, what we need to have is 2L plus 3W. Okay. Now, the other equation we're going to have, because it asks what are the dimensions that maximize the area. Well, then we need to come up with an area equation, because that's what we're trying to maximize. Well, the area is equal to length times width, because it doesn't matter if this is all weird. You still have one giant rectangle here, and you have that length and that width. So, yeah, absolutely, it's still just going to be length times width for the area. Alright, so again, we have 2 equations with both L and a W in it. So we're going to do substitution just as before. So in this one, let's see, let's subtract 3W. Divide by 2. And we get that L is equal to 225 minus 1.5W. Now that we have L isolated, we can take that and substitute that into the L in the area equation. So the area is equal to 225 minus 1.5W times W. Distribute this, and as I'm distributing it, I'm going to go ahead and swap my terms around, because I want to have my quadratic term first. You don't have to, that's just a personal preference. Alright, so this is my area equation. So we've finally done sort of all the background work that needs to get done. So it asks, what are the dimensions that maximize area? So we want to maximize the area. Well, here's our area function, so if we want the value of W that will give us the most area, we're looking for our vertex. So negative B over 2A will give you the W that will maximize the area. So that's a negative 225 over 2 times negative 1.5. And negative 225 divided by negative 3 gives us a value of 75 feet, because that's W. So when W is 75 feet, we have the maximum area. But it doesn't just ask us for W, it wants the dimensions. Well, we have W. To find out L, up here we know L is 225 minus 1.5W. So down here, I'm going to find out what L is by substituting in 75 into this, and that gives us that the length is 112.5 feet. And then the other question asks, what is the max area? To get the maximum area, there's 2 ways you could do it. Now that you know both the length, and let me use a little bit of color up here. Now that you know the length and the width that'll give you the maximum area, you could just multiply those together. Or, since this was a value that gave the maximum area, you could plug that in there. So to get the max area, you would do f of 75, so that's negative 1.5 times 75 squared plus 225 times 75. And that'll give you a value of 8,437.5 feet squared, because remember, area is a square term. So your answer on this could be the dimensions that give the max area, and that max area was 8,437.5 feet squared, are 75 feet by 112.5 feet. And again, you want to sort of stop and look at it and see if it makes sense. The W's are 75, so if you put 75 here, where every place there's a W, and 112.5 every place there's an L, if you add all of those up, all 5 numbers that are there, you will get 450 feet, which is what you're supposed to get. And if you multiply 75 times 112.5, you'll also get that. So everything does work together, and it does have to make sense. Alright, in a minute you'll be practicing some. Good luck.